In this video, we're going to be talking about the differences between linear, exponential, and quadratic functions. Now, in math, many things can be represented in different ways. And what we see here, we're representing these three different functions as an equation, as an XY chart or numerically, and then as a picture or graph. So let's examine linear functions first. A linear function has common differences, meaning the slope for those are always the same. So my graph, or excuse me, my equation is y equals 4x minus 3. And this is kind of what a linear equation would look like, right? You have the y equals mx plus b form, and it doesn't have to be in this, but you only have x's and y's with no known x or no shown exponents. And then we're just multiplying numbers and variables together and adding and subtracting numbers on as well. So nothing too terribly unique about those. In the numerical version, the XY chart, notice that as the x's go up by 1, from -2 to -1 to 0 to 1 to 2, that the y's are going down by 3. 4 minus 3 makes 1, minus 3 makes -2, minus 3 makes -5, minus 3 makes -8. And those are the common differences that we note. In this version, this table of values, I could tell you that my slope is -3 over +1, or just -3. And in the graphic version of this, this is kind of what a line looks like in the red there. I mean, we've done plenty of lines, we know what they look like, and this is linear. Let's move on. An exponential function has common factors. So in the equation, notice that my exponent is where the variable sits. That's a big tip-off that we have an exponential function. And in that, as I increase my x's by 1 each time, I'm repeatedly multiplying by a half. Now, in the table of values, again, I just have my x's going up by 1 each time, so just add 1 to each as we go off to the right. But then the y values are repeatedly multiplying by 2. 2 times 2 makes 4, times 2 makes 8, times 2 makes 16, times 2 makes 32. And so that's what a common factor looks like, repeated multiplication. Now, the graph of an exponential function kind of creates that hook to a certain extent here. If you remember, one side is heading to an asymptote, and notice here it's the left side is approaching some number but never actually getting there. It really visually looks like it's flattening out, but it's still always going down, just not quite at the speed that it was before. And on the other side, it's skyrocketing. So as we go off to the right, it's getting higher and higher and higher very quickly. And that's what an exponential function looks like. How about a quadratic function? A quadratic function has common second differences. So the equation version of this is always going to have an x squared to it. So y is not being squared, but x is. And we could have this other stuff added and subtracted at the end. But a simple y equals x squared is going to be enough to know that we have a quadratic. In the numeric version, notice that we just repeatedly add 1 again for the x's. And it doesn't have to be the numbers -2 to 2 each time. These are just the numbers I picked to be consistent throughout. But again, as long as it's a consistent change from whatever your x values is, repeatedly adding or subtracting the same number each time. And then we have to see what our y's are doing to see and make sure they complement those. Notice that the first differences are not the same. We have to subtract 3 to go from 6 to 3, then subtract 1 to get to 2, then add 1 to get to 3, then add 3 to get to 6. But the second differences, the differences among those first differences, are the same. We add 2 to go from -3 to -1, then add 2 again to get to +1, then add 2 again to get to 3. And those are now equivalent, and so that indicates to me that we have a quadratic function. And then lastly, the graph here, we know that a quadratic function is going to look like a parabola. Okay, and this parabola could open up or down. This one opens up, but that is what a quadratic function looks like graphically. It's going to make a parabola. Okay, so that's what is going on here and the difference between these different functions. For now, we are done.